Let's be honest, I don't want to see that for an hour.
We both realized.
Please work. This is only going to be the same box for the rest of the day. After school, I'm getting a new box. Which means I need 2 more people to buy things.
Okay, yeah. Can you do 3B? I don't understand how I got that. That must have nice.
Huh?
What'd you get for 3B bars? I was like,
I got 3.8.
I can just draw a line over it. But should I type out one too? Yeah. I'm just gonna erase it. Exactly. Yes. This is the deciding factor. What'd you get for 3B for the deviation?
My knife.
What?
What?
Should I get that?
Why should I? Aren't you supposed to do it?
Oh, Sam.
No, we're not worried about the game. We're worried about the
Or population, standard deviation.
No, for the pink just texted me. I was like, oh, I didn't get to show you my knife necklace, and I was like, should I be concerned?
They look crazy.
Okay.
I'm not okay. I'm not okay. I'm not okay. I'm really not okay. Censorship. Censorship. I'm recording. Just hope you know. Someone's gonna be watching the video tonight and they're just gonna get a face full of censorship.
That's what you should do. Instead of eyes, you should write censored across.
Well,
You should create something like that. That would be
I have done something like that somewhere.
And then like
Yeah, but I mean, we talked about this yesterday, didn't we? Didn't we say that
I don't know, something
the
really
real world comes
Because this was kind of comic inspiration, so I'm not very good at drawing body proportions. So right now you have slightly aggressive Hades.
So, all right. Good morning.
Just depends. Persephone.
As we look at number 4, it says that the histogram shows the distribution of the number of automobile accidents per year for every 1,000 people in different occupations. Describe the shape, center, and spread of this distribution. So we start by talking about shape. Symmetrical? Everybody agree with that? Yeah. Did I draw that poorly? Yes. Or is that okay?
It's fine.
It's okay. I don't like it. I do it like this. Is that still okay? Yeah. What would you say about that drawing? Looks skewed to the right, doesn't it? Okay. Is there anything wrong with this drawing? No. That's not a good drawing. I don't like that one. I don't like that curve. Let me do it better. Is that a fair drawing? Okay, tell me about that one.
Looks not symmetrical.
Yeah, pretty normal. So, what are you telling me?
Depends on how you draw.
Depends on how you draw it. Were either of them drawn incorrectly? No. So, yesterday we discussed, or the day before, I can't remember which day, we discussed the fact that your answers, your explanations are going to be important. In this case, your explanation in terms of the shape of the distribution is going to be how you draw the curve, right? Both of those were fine. So, because I mean, this isn't a slam dunk in terms of which it is. It's, you know, you could argue that it's skewed, you could argue that it's normal. Just depends on how you argue it. So I think that the plan was for it to be normally distributed. I'm 50-50 on that, but we can play it out like that. But anyway, my point is, in this case, your argument is your drawing. So every time you answer these questions, you're going to make an argument. And so make sure that your arguments are convincing, that they're not things like normal. Give more. When we draw the curve, in this case, this looks like a normal curve, and we're fine. Okay? Center.
Ninety-one.
89? 90?
I said 91.
I said 91.
So 89 would put us right about there. Does that look like a reasonable? What would that be, by the way? Would that be the median? Mode, the mean?
The median.
Would it be mode in this context? Because it's highest bar, usually occurs the most.
The mode would certainly be the between 89 and 93.
Yeah.
But typically when we're talking about the measure of center in this type of a graph, what are we talking about?
Median.
Mean. When we deal with normal curves that are evenly distributed, we will typically talk about mean. Do you feel confident that it is exactly 89?
No.
No? Anybody have any other answers besides 89?
I mean, the way it looked, the way I drew it, it looked like mine was 91.
91? Okay. 90? To me, all of those are perfectly fine. If you told me that the mean here was 91, I'm good with that. What about 88? Could we go down to 88?
Yeah.
Probably.
Probably not.
But I would guess somewhere between 88 and 91. But see, here's the problem. We don't know exactly what these numbers are, right? Because they're all in groups of 4. So between 89 and 93, well, that could be 92, 92, 93, 93, 92, 93, 92, 93, with no 89s or 90s. Or it could be the other way around. We just don't know. So there's no way that we can be perfectly accurate. We can say from looking at this that it looks like it's between 88 and 91. It's conceivable that we could be off by a little bit. But I do feel confident that we can't be off by a lot. Fair? Okay. So the mean should be somewhere in that range. And if you picked a number that's in that range, perfect. That's fine. Okay? Spread. What are we talking about at this point when we talk about spread? Standard deviation. Yep. Standard deviation. So what are we talking about from a standard deviation point of view here? What would you guess?
Like,
So what are you thinking?
I said it's 10 because I put my mean at
You said 10 because you said it would go from what?
Well, I put it from 91 on mine.
Okay, so you had 91 as the mean, and then you said that it was the standard deviation was 10. So from there to there. You think that's fair, everybody?
Yes.
I absolutely think that's fair. You have the majority of the info, but not all of it by any means. So that's cool. Anybody do anything else? Yep. You said 89 with a standard deviation of 8. So you still went to 81. but you went up to 97 instead. What do you think about that? I think that's good too. I got no problem with that either. I would say those are kind of one end or the other. Standard deviation probably between 8 and 10. I don't think it's going to go much higher than 10. With a mean around 89 to 91. So anything that you have in that range, I would say is good. Okay? Better? All right, anything else? Okay, you may have figured this out or heard it from friends or something like that, but we can try something a little different this unit. We have somebody who has been mad at me for the last week and a half saying, give me something to do. That's Rachel. So we're going to give Rachel some work to do over the next week and a half. The plan is this at this moment. The plan is to, no, you got to listen while I'm saying this. The plan is to give you back your homework next Wednesday. Test is Friday. Okay, so that gives, you still have your notes, but if you want to use your homework to study, that would give you 2 weeks. Is that fair? Okay, so, you guys can start the basket. Put anything you want to put in the basket, send it around. After it's done, give the basket to Rachel. Rachel's in charge, she's the boss. If you don't have it today and want to do it, need to give it tomorrow, that's fine. But you know how we feel about getting things done on time, okay? Yes, sir. No. Oh, you have to come in after the game. I'll leave it in.
Anybody else see the basket?
Where do you guys go today? Where do you go? Chaparral? Ooh, up my neighborhood, Scottsdale area. Just give it to Rachel.
Oh, okay.
Do you need more guidance from me to enroll in, or? Good luck, gentlemen. My guess is after day 1 or day 2, you'll be rolling.
Fast food on silver.
Okay, ready? Oh, I got a handout. I just need that.
Fast food. I know you're going to the hospital to fast food. Thank you.
Covered the phone when you did that.
Oh. Oh.
No.
Whoops.
Don't stop.
Okay, it's good now. Oh, sorry.
She's gonna be mad at you.
It's fine. I'm just gonna go back and watch it and realize it's fine.
I legit didn't see it.
My earrings. What?
Why does everybody say I used to? Why does everybody stop this stuff?
I don't know why I stopped, but that's a good question. Everybody asks me that. Why do I stop? Because the coach here,
I remember
told me
these.
to play, and last year, I don't know what, I guess I was gonna play, and then I didn't. What?
These graphs, I remember them.
He still wants you to play, and it's just like, I don't know.
You can go 3 with that. Oh.
Every day.
Okay.
Every day.
We are going to, by the way, just to give you a heads up, I'm sure I'll talk more about it as the week goes on. We are going to make a change in the order that we do the sections. It doesn't really matter to you guys, but on Thursday, the day that I am out, we are not going to do 3A, we're going to do 4. We're not going to do 3A, we're going to do 4, and then we'll do 3A when I get back on Friday. So there's less
That's not bad.
necessity for me on, what are they calling it? 10, on 10-4 than there is on 10-3. So that's the plan. Right?
Yes.
Ready?
Ready? Is the
Okay.
answer yes?
Yes.
Okay,
Yesterday.
perfect.
Yesterday we pretty much dealt with, and if you look at your notes from yesterday, the title is Distribution, Shape, Center, and Spread. Okay, she has the front here, so I will check that in the office. Okay, thank you. Today's lesson says skewed distribution, shape, center, and spread. So we're going to talk more about the skewed stuff, and we'll see how that plays out. Yesterday we dealt with mean and standard deviation. Today we're going to talk more about median and interquartile range. So you guys know how to get a median, correct? How? What do you have to do before you start counting off?
Put them in order.
Put them in order. Either increasing or decreasing, doesn't matter, just they have to be in order. Okay. Once you get the median, you have now split the data into a lower half and an upper half. Fair? What percentage of the data is in the lower half? 50%. That's the name, lower half. And the upper half, 50%. That's what a median does, is it splits the amount of data in half. To get what we call the interquartile range, and we saw that yesterday in our list of measures of spread, right? We put that, we had range and standard deviation and interquartile range, right? Okay. So to get the interquartile range, what we need, first of all, are what we call quartiles. And there are 3 different quartiles that we're going to come up with, and that they split the data into 4 different groups. Okay? So quartile 2, Q2 that they talk about here, we will never, ever talk about Q2 again. Q2 does not mean that. It really means the median. So that's the last time you'll hear me use that letter and number combined. And we'll just talk about that. Once we get the median and it splits it into a lower half and an upper half, we're then going to get the median of the lower half and the median of the upper half. The median of the lower half is Q1, and the median of the upper half is Q3. Now sometimes Q1 is called the lower quartile, and sometimes Q3 is called the upper quartile. I'll probably use them pretty much interchangeably. I've used both quite a bit. So if we talk about the lower quartile and the upper quartile, we're talking about Q1 and Q3. Once we have Q1 and Q3, the interquartile range is very simple. It's a lot easier than finding the standard deviation. The interquartile range is simply Q3 minus Q1. So we'll just subtract Q3 minus Q1 and we will be done. Okay? Let's see, 3 quartiles divide the data into 4 equal parts. The upper quartile, Q3, divides the top half into 2 equal parts. Lower quartile divides the bottom half into 2 equal parts. Middle quartile is the median. The upper and lower quartile values are used to determine the interquartile range. You may remember these measures are displayed using a box plot. You may have heard box and whisker graph in the past or things like that. Okay? Box plot, box and whisker graph, either way, they're the same thing. Okay? Questions on interquartile range, Q3, Q1? Nothing there? Okay. Since the median splits it into a lower 50% and an upper 50%. Then the quartiles take the lower half and turn it into 25 and 25. And the Q3 turns the upper half into 25 and 25. So in each area of the box plot, we have 25% of the data. Okay? All right, let's see how that pertains to some of this stuff here. What is the, A, what is the median of this data? Can you tell from looking at this box and whisker plot, what is the median of the data? 30 is correct. The line that goes through the box is the median. The line that goes through the box is the median. What is the value of the lower quartile?
20.
Anybody know from the 20? 20 is correct. The box starts at Q1.
Bless you.
Thank you. And ends at Q3. So the lower quartile is
40.
20.
Wow, 20.
What is the value of the upper quartile?
45.
45.
Bless you.
Thank you. Can we now get the interquartile range?
Yes.
What is it?
25.
25.
Upper quartile, Q3, minus lower quartile, Q1. 45 minus 20. So the IQR is 25. Questions there? Good. What percent of the data falls between 10 and 20?
0.
Okay, maybe I didn't explain this well. Let me go back. To draw a box and whisker plot, you actually need 5 numbers. Okay, five data points, if you will. You need the lowest value, so the minimum. You need the Q1. You need the median. You need Q3. And you need the maximum value. You draw the box around Q1 and Q3, a line through the median, and then the whiskers go to the minimum and the maximum values.
Out of the points, how do you know which one's
Q1 is always the left edge of the box. Q3 is always the right edge of the box. Is that what you're asking? Or
No, like when you draw it.
when we draw
How
it?
do you find Q1?
That's what we were talking about up here. We find the median, then we find the median of the lower half, that's Q1.
Oh,
Then we find the median of the upper half, and that's Q3. Have you ever seen this list of numbers, minimum Q1, medium Q3, maximum before?
Yeah.
Where?
Middle school.
More recently than middle school?
Calculate
Yesterday,
yeah.
when we did our list. And remember how we got the list, we did one variable stats, and it gave us the standard deviation and the mean and everything? And then I said, if you scroll down, it has some more stats. Well, those more stats were exactly these 5 numbers. Minimum value, Q1, and it even says Q1, right? Median, Q3, maximum value. Okay? So it just gives you the 5 numbers, and that's all you need to draw it. If you don't plug it into a calculator, find the median of the lower half, Q1, find the median of the upper half, that's Q3. Is that better? Okay. What percent of the data falls between 10 and 20? 25%. Each part of this box and whisker plot, whether it's a whisker, first part of the box, second part of the box, other whisker, they all encompass 25% of the data. What percent of the data falls between 20 and 45?
50%.
50%. What is the highest value indicated on this graph?
50.
50. It's out here, that's the maximum. What percent of the data is less than or equal to 45?
75%.
75% is correct. Brooklyn, did you get your question answered?
This is not a pencil. I always use this as a pencil.
Questions on that? Suppose the data in the box plot represents overnight low temperatures recorded during the month of January. Interpret the median and the IQR in the context of the data. In other words, tell us something that normal people that don't know anything about this would understand.
Are you saying
The average.
Average temperature. We can use the word median.
Oh, the median.
The median,
temperature is 30 degrees.
the median low temperature. Okay, not the median temperature. Because this just says overnight lows, so overnight low temperatures. So the median,
Overnight low temperature.
overnight low, the median low temperature is
30.
30 degrees. What's another way of phrasing it if we wanted to phrase it differently than that?
The average overnight low temperature is 30 degrees.
Since it's median, what is that basically dividing it into?
Half and half.
Half. So use that to interpret. You're telling somebody that doesn't know anything about what's going on what the deal is. So tell somebody that's not a math person about this.
The middle temperature of the lows is 20 degrees.
Start with the word half.
The half of the time the temperature is 30 degrees.
Half of the nights the low temperature is
30 degrees. Below.
not 30 degrees, but
Below.
below 30 degrees. And the other half the time, the low temperature is above 30 degrees. Is that okay? Half the nights the low temperature gets below 30, half the nights the low temperature is above 30. IQR, that's a little bit more difficult to put into a perspective. What I would probably say is that half of the nights, IQR, there it is, 25. Half of the nights, the IQR is between 20 and 45. Right? Because half of the nights are inside this box. So half below 30, half above 30. 50% of the nights are between 20 and 45. Explanations are big at this point. Questions on that? How are we doing, Rachel? Anatomy? She says that's it. I wanted to do work and now I totally go against that. No more. I know you did. All right. So now we're going to get a bunch of box plots. We're going to talk about them. We are going to describe the distribution, including shape, center, and spread.
That's what she said. Sorry,
So look at A.
that time of day.
Talk to me about shape. Very symmetric. You agree with that? Normal curve, not skewed.
Yeah.
I would agree. So that's the shape. Tell me about the center.
50. 8.
So are you saying that the mean is 50?
Possibly.
Mean or median?
Median.
Okay, you gotta say that. All right? When you're talking about the center, make sure that you're saying which measure of center, which measure of center you're using. So in the case of the center of A, we would say that the median is,
50, around 50.
yeah, I don't like 50.
It looks like it's higher than 50.
It does look like it's higher than 50.
55.
So you guys are smart. You guys are the interpreters of what's going on here. Okay, interpret.
Maybe it's like 55.
What do you think the median is?
55.
55?
I see 50.
What are you going with? 54? Okay. Anybody else going with a different median? 55? Any others? Or are you happy with that? I might go 53.
I did 50.
But I can handle 54, I can handle 55, I can probably handle 52. But get in there on these. Don't just say, yeah, it's about 50. Because is it about 50? No, I would say no, it's not about 50. It's above 50. So get as deep into it as you can. All right? What about spread?
It's spread evenly. Looks like 10. That would be 64.
That's one of the questions that I want you to
I'd say
answer.
30. 20.
So what are you telling me about spread? Well, it kind of depends, doesn't it?
What's your median?
What does it depend on? Depends on what measure of spread you're using, doesn't it? What measure of spread are you using here? Is that what you're using? Okay. Then you better say that. Right? Because some people are saying like somewhere around 50, correct? Is that what people are saying? 50, a little more than 50, something like that? Do you think, let me ask you this, do you think that the standard deviation is around 50?
No.
No. Why not?
It's too big.
All of the data.
Because that would take care of all of the data, right? If we added 50 to this, we'd be out here, and if we subtracted 50 from this, we'd be down here. That would be all of the data. So when you're saying, again, we said you got to talk about whether you're talking about median or mean. You better tell us whether you're talking about standard deviation or IQR. Okay? So, tell me about spread.
I still think 20 is not good.
What is?
Usually 25.